Hello everyone, I'm Dr. Wen. Here is the question. Find the minimum value of this trig expression. This expression is very complicated. The outside is the absolute value sign. The inside part is the sum of 6 different trig functions. Here, x is a real number. This is a very challenging question. What is the basic idea to solve this question in order to find a minimum value? Too many variables here to handle. The basic idea is to convert every function into cosine. If we only have one variable, it's easy to handle to find the minimum value of this expression. The question is how to convert these 6 trig functions into one function, cosine. We define f is the inside part of the absolute value. In the first step, we can rewrite each function in terms of sine and cosine. Tangent equals sine over cosine. Cotangent equals cosine over sine. Secant equals 1 over cosine. Cosecant equals 1 over sine. The question is to find the minimum value of the absolute value of f after we defined f is the inside part of the absolute value. We can simplify the sum of middle 2 terms and the last 2 terms. We consider the common denominator, which is cosine x times sine x. The numerator is sine squared plus cosine squared. The numerator here is sine x plus cosine x. From the basic result for sine and cosine, we have sine squared plus cosine squared equals 1. Sometimes we also call this is a Pythagorean result. In this expression of f, we have 2 terms. That's sine x plus cosine x. Sine x times cosine x. The question is, can we convert sine x plus cosine x and sine x times cosine x in terms of cosine? Let's consider sine x plus cosine x. This equation is always true. You can simply check the algebra here. Square root of 2 times square root of 2 over 2, which is what? Square root of 2 times square root of 2 over 2 is what? Why are we doing this? We can rewrite square root of 2 over 2 as cosine of pi over 4, as sine pi over 4. Based on the difference formula of cosine, we have cosine, cosine, sine, sine, here's plus. The second part is cosine of the first angle minus the second angle. We have square root of 2 outside. If we define y equals pi over 4 minus x, then we have sine x plus cosine x equals square root of 2 times cosine y. Now we converted sine x plus cosine x into cosine. Let's convert sine x times cosine x. This is simple algebra. 1/2 times 2 is 1. What is the inside part of this parenthesis? This is the double angle formula, which is sine 2x. The question is, can we convert sine into cosine? Yes. Sine equals cosine 1/2 pi minus this angle. We can factor this 2 out. What is pi over 4 minus x? By definition, which is y. Therefore, sine x times cosine x equals 1/2 times cosine 2y. Now we are ready to rewrite f in terms of cosines. Sine plus cosine equals square root of 2 times cosine y. Here, we can replace it by square root of 2 times cosine y. The denominator we can replace by this one. We have the same denominator. We can put 2 in the numerator. Denominator is cosine 2y. Cosine 2y. Merge the last 2 terms together. We can factor 2 out. We can define c as square root 2 over cosine y. Square root 2 times cosine y. From here to here, we use the double angle formula. Cosine 2y equals 2 cosine y squared. Square root of 2, we can consider that 2, we can consider that's the square root of 2 squared, which is square root of 2 cosine y and then square. That means we have c squared here. Now we factor 2 out. Denominator, that's c minus 1 times c plus 1. C plus 1, c plus 1 here can be cancelled from both numerator and denominator. Then we have f equals c plus 2 over c minus 1. So here c cannot be 1. If c equals 1, f equals infinity. We only care about the minimum value, not maximum. So here, we don't consider c equals 1. Only 2 other situations we need to consider. The first situation is c bigger than 1. Then we will discuss c less than 1. If c is bigger than 1, the absolute value of f equals the absolute value of c plus 2 over c minus 1. Because c is bigger than 1, the denominator is positive. The inside part is positive. Therefore, we can directly drop the absolute value sign. The absolute value of f equals c plus 2 over c minus 1. We put the negative 1 here, plus 1 here to keep the balance. Why are we doing this? We are going to use an important formula to derive the lower bound by the geometrical mean and arithmetical mean inequality. This is inequality. If x and y are bigger than or equal to 0, x plus y is bigger than or equal to 2 times square root of x times y. Originally 2 is here. X plus y over 2, that's a arithmetic mean. Square root of x times y is the geometric mean. The sum of the first two terms, we can use this inequality. X, in our case, is c minus 1. Y is 2 over c minus 1. C minus 1 here is positive because c is bigger than 1. Apply this formula. The inside part c minus 1 and the c minus 1 from the denominator can be canceled out. We only have 2 left inside of the square root. Therefore, the absolute value of f is bigger than or equal to 2 times square root 2 plus 1. This is the lower bound when c is bigger than 1. We also need to consider c is less than 1. Find the lower bound. Then compare which one is smaller. If c is less than 1, we rewrite the inside part as 1 plus c minus 1 plus 2 over c minus 1. So here, minus 1 plus 1 cancel. Then we swap the locations of c and 1. So 1 minus c, 1 minus here c minus 1. If we swap, we have to put a negative sign in front. Now, the inside part is a difference of 2 parts. What are we doing here? We want to check if the inside part is positive or negative. Check the second part. This is the second part because c is less than 1. 1 minus c is bigger than 1. 1 minus c is bigger than 0. 1 minus c is bigger than 0. Therefore, the condition of the inequality is satisfied. Then we have the result. Apply the inequality for the sum of the first 2 terms, which is bigger than or equal to 2 times square root of 2. Similarly here, we can cancel 1 minus c from both numerator and the denominator. Now look at the inside part. 1 and the second part. The second part is bigger than 2 times square root of 2, which is bigger than 1. So the second part is bigger than 1. The difference is negative. How to drop the absolute value sign if the inside part is negative? We have to put a negative sign in front. Negative 1, negative 1. Negative, negative become positive and become positive. Now, look at the sum of the last 2 terms. We use this result again. What is this result? This part is bigger than or equal to square root of 2 times 2. This lower bound is smaller than the one we derived before. So we should use this one. This is just a small bound. The question is it reachable? Next thing we need to do is to check if we can find a c such that the absolute value of f equals -1 plus 2 times square root of 2. By our definition, c equals square root of cosine y. Y as defined as pi over 4 minus x. Therefore, the c value is between square root of 2 and negative square root of 2, because the maximum value for cosine is +1. The minimum value for cosine is -1. we only need to find the C value inside of this interval such that absolute value of f is equal to -1 plus 2 times square root of 2. The equal sign is true if x equals y for this inequality. In our situation, x equals 1 minus c, y equals 2 over 1 minus c. This is a quadratic equation. You can simply simplify this equation by both sides timing 1 minus c. Solving this quadratic equation, we have two values for c. 1 plus square root of 2 and 1 minus square root of 2. Because we consider c less than 1 now, so we only have one solution satisfy our condition. C equals 1 minus square root of 2. If we replace c by 1 minus square root of 2 in this expression of the absolute value of f, we have the result -1 plus 2 over square root of 2. This means the minimum value is reachable when c equals 1 minus square root of 2. The final answer is the minimum value of absolute value of f equals -1 plus 2 times square root of 2. That's all. Thanks for watching, and see you next time.